Welcome to this Solidworks tutorial, guys. In this tutorial we will be finding these shear stresses and perform finite element analysis on this part in Solidworks. Also we will be running this simulation on true scale as well. First we will make this first part and then this second part in Solidworks, and then we will assemble this, and after boundary conditions we will be doing this analysis in Solidworks. So let's begin. Click on part and click OK, and now we are going to design the first part in Solidworks. So change the background to plain white from here, and here make sure that you are working in mmgs as units that are in millimeters. After that click on front plane and click on sketch, and from here select the center rectangle and make a center rectangle at this origin like this. Now let's define it. For that select smart dimensioning tool, and here specify the length of this line as 100 millimeter and the height of this line as 200 millimeters. And after that select here a center line for reference. This center line will be used for mirror entities, and this vertical reference line as well. Now select circle, and here create two circles, one here and another one at this origin like this. Now both of these circles should be equal, so hold control key, select these two circles, make relation equal, and after that specify the diameter of one circle. You can specify any one. This is 10 millimeter, and as you can see both of the circle have same diameter. Now the height between these two centers is 32 millimeter, and now we are going to use the mirror entities tool. So select your mirror entities. In this window I am selecting this circle, and mirror about window this horizontal reference line, and as you can see this circle has been mirrored. Now go to features and select extruded boss base, and here define the thickness for this plate, which I am defining as 8 millimeter, and check this box. Now as you can see our part 1 is ready, so click on file and save this part as part 1 in any folder you like. Now we are going to make part 2. For that cross this one, click on file, click on new, select part here and click OK. This window will get open. Similarly we will do some repeating steps, making sure that you are working in millimeters. After that click on front plane and click on sketch, and from here select center rectangle and create a center rectangle at this origin like this. Now select line and make a vertical line here. Now select this line and make it as construction geometry, which means center line. Then make here inclined line like this, and after that make a center line. This should be horizontal and it will be used for mirror entities. So now select here mirror entities and select this line, and in mirror about window select this horizontal line, and it got mirrored. Okay, now let's specify the angle between these two lines as 75 degree, and angle of other line is automatically defined because it was mirrored. Now make here a center from this center point to this line here, and make this vertical line construction geometry. Now select trim entities, and you need to trim this line. Okay, and after that make here a circle. Now select trim entities again and trim this internal arc like this, and after that make here sketch fillet of 201 radius and above here as well, and after that check this box. Now let's define. For that select here smart dimension, and here define 100 millimeter as the length of this line, and similarly 136 millimeter length of this line. Now make here 3 circles The third circle would be mirrored. These two circles should be equal, and here define 36 millimeter the distance from the edge and 32 millimeter the distance from each other. And now let's specify the diameter of one circle, which is 10 millimeter. Automatically the second circle will be having the same diameter. Now I am mirroring this circle about this horizontal line because we need 3 circles. And now select Smart Dimensioning tool, and here specify the diameter of this circle, which is 10 millimeter, and from this midpoint to this midpoint we gonna have the diameter as 200, and radius of this circle is going to be 35. And after that go to features and select extruded boss base, and here define 8 millimeter the thickness for this part. Now as you can see our part 2 is ready, so let's save it. For that click on save as, and here you can rename it as any other name and click save. Now select here make assembly from the part and click in this environment. Automatically part 2 will be opened here. Change the background to plain white, right click here and make it as float because I do not want to make this as fixed. Now click here insert component, and here select part 1 and click open. Now select this part and make it as fixed because one of parts should be fixed. Now click on mate and select this internal circumference and this one as well, and as you can see the part is starting to get assembled. Now select this face and this face, it will get assembled like this. And now we need one more mate, so select these two circumferences to completely assemble it, and as you can see they are not moving, which means that they are perfectly assembled now. Now drop down this menu and select add-ins, and make sure that you have enabled SolidWorks simulations from here and click OK. Now go into simulation tab and click on this new study, and after that you need to click on this static and click OK because we are doing static structural analysis. Now we need to define some parameters here, so right click here on this part and click on apply material, and here we need to select any material for our case. So I'm selecting this plain carbon steel, and after that click on apply and click on close, and as you can see the color of this part has been changed, which means the color material has been applied. Right click here on this fix geometry. I want to fix this back side of this part 1 and click OK. So there are going to be many boundary conditions. Right click here and click on this roller fixture, select this face and back of this of part 2 and click OK, and then let's apply some force. So in this I'm going to select this hole, and to make force downward I have to select this option, and then I need to select a plane. So in my case this is going to be this plane, the top plane, and since I want downward force, so select here metric as units, and here we need to select any of this which will enable us to apply up or down force. As you can see this force is upward, and you can reverse direction to achieve force on downward direction. And here select 12 kilograms for the force, and after that you can select here this checkbox. Now let's define the local interaction. For that right click here on connections and select local interaction from here, and since I want this to be automatically found, so select here automatic, and here we need to select both of these part, the part 1 part 2, and when you click on find local interactions, which will be this option, and as you can see the local interaction is automatically being found. Check this box and click on yes from here, and right click here on connections and here select bold, and we need to define parameters here for these three circles. In this window, select this upper edge for this hole, and in the next window select this edge for the same hole. And after that, scroll down and these parameters are automatically found. Keep these options as it is, and here select strength data, and here we need to define 1.75 for the thread, and we need to check this keep visible option. After selecting this keep visible option, click on check mark, and here we need to define simply the upper and lower portion of the other circles. Finally the third one, this one, and in the next window the back side of the same circle, and click OK. The same parameters are defined for other circles as well. Now cross this one, and as you can see 3 bolts and nuts have been appeared. These are 3 fasteners. Now right click here on the mesh and click on create mesh, and you can define mesh parameters from here. I'm selecting here 5 mm as size of the mesh, and check this box from here. Now we need to simply run the study. For that, select this option from here. It will take some time, and now the study is ready, results are ready, and these are the values for the stresses. And right click here on the displacement and click on show, and these are the values for the displacement and same for the strain. So we have got these values. Now in displacement, here select added definition, and in this option enable minimum and maximum value option, and these are the maximum amount of displacement and minimum amount of displacement which are showing here. So now right click here again and click on animate, and this is running on the true scale. Now right click here on the displacement and click on edit definition, and make this value as floating because we do not need scientific. And here select automatic rather than true scale, and check this box from here. Now it will show us the exaggerated animation. The part will have this displacement. This is exaggerated. In real world it is very small. Now right click here on result and click on define bolt pin, and check this box from here and click on details, and here we have the stresses for all of these 3 bolts as you can see it from here. So that's it for this tutorial, guys.